Welcome to the Explainer. Today, we're diving deep into NS3, a super powerful network simulator. We're going to break down one of its key tutorials to see exactly how a little packet of data makes its journey from a Wi-Fi device across a hybrid network to a wired server.
So let's kick things off with a huge question. Real-world networks are this messy mix of wired and wireless tech, all supposed to play nicely together. How in the world can you predict how they'll actually perform without, spending a ton of money on hardware first? Well, the answer is simulation. You build a digital twin, a perfect replica of your network right inside your computer. And today, we're exploring one of the core NS3 examples that does just that, showing us how a signal travels from the airwaves to a server on a cable.
Okay, let's get into it. Before we can send our data anywhere, we need a map. We have to chart out the digital world that our little data packet is about to travel through.
And here it is. This is the network layout from the third.cc script. Up top, you've got the Wi-Fi zone with a few mobile stations, or STAs. Just think of these as our phones or laptops. They all talk to a central access point. That AP then connects to a wired backbone, which finally leads down to a wired CSMA LAN. And if you're curious, CSMA is just a fancy way of saying there's a protocol that helps devices on a shared cable take turns talking. It's kind of like a traffic cop for data. So this whole story really has three main characters. You've got the mobile Wi-Fi devices, our little travelers. Then there's the access point, which is the super important bridge between the wireless and wired worlds. And finally, you have the destination, a server just sitting on a traditional, fast, wired network. So how does this map actually get built inside the simulation? Well, it all comes down to the code. The script defines three totally distinct network environments for our data packet to navigate. The code creates three separate subnets, and each one gets its own IP address range. It's really helpful to think of these like different neighborhoods. You have the bustling Wi-Fi neighborhood where the users are, the main backbone street that connects everything, and then the server's quiet business park. This kind of separation is exactly how real-world networks are designed for good organization and security. And this is what makes simulations so powerful. The code explicitly sets different speeds and delays for each part of the network. The backbone link is set to a slower 5 megabits per second, but the destination LAN is a blazing fast 100 megabits. This lets us realistically model where things might slow down, to find those potential bottlenecks before they become a real problem.
All right, time for the main event. Let's see how this all comes together. We are now going to follow one single data packet on its entire trip, from the moment it's created in the wireless world to the second it arrives in the wired one. Our packet's journey begins on a Wi-Fi network, and this one little line of code is what gives that network its name, its SSID, NS3-SSID. This is literally the name your phone is looking for when it scans for Wi-Fi networks nearby. Now here's something that's really cool. The simulation models movement. The Wi-Fi stations aren't just stuck in one place, they use a random walk mobility model. This is a fantastic way to mimic the unpredictable movement of real people, wandering around a coffee shop or across a campus. But the access point, it's locked down with a constant position, just like that piece of hardware bolted to the ceiling in real life. So you might be wondering, with all these different networks and moving pieces, how does our packet know where to go? Well, this one command right here acts like a network-wide GPS. It automatically figures out the best routes between all the devices and then populates everyone's routing tables. It basically tells our packet exactly how to get from that Wi-Fi zone all the way to the wired LAN. So let's trace the path. First, a UDP packet is created on a moving Wi-Fi device. The script uses UDP because it's simple and fast, perfect for a quick test. That packet then makes its first hop through the air to the access point. At the AP, it gets stripped of its Wi-Fi packaging and gets a new wrapper for the wired world. Then, it zips across that slower backbone link, crosses into the super fast LAN, and finally, bam, it arrives at the server. It successfully navigated three different network technologies. Okay, we just followed one tiny little packet on its journey, but let's zoom out for a second. What's the big picture? Why is this specific simulation, this third.cc script, so fundamentally important to understand? It's because this simple setup is actually a blueprint for modeling unbelievably complex real-world systems we use every single day. We're talking about your university's campus network, the Wi-Fi at a huge corporation, or even the little IoT gateway that connects all your smart home devices to the internet. This simulation is the foundation for all of that. And once you master this, you're ready to start asking much, much bigger questions. You can start seriously evaluating wireless performance. You can design new protocols that actually adapt to people moving around. And you can conduct real, research-grade experiments to invent the next generation of network tech.
By understanding these basic building blocks, you now have the tools to model and test pretty much any hybrid network you can possibly imagine. So really, the only question left is, what are you going to build next?